Welcome to your guided practice for Unit 7. So let's start by going over some academic vocabulary that you'll need to memorize for the test. It says define the following terms. Reactant. Reactants are to the left of the arrow. They are what react in a chemical reaction. They're the before. Product, it's what's to the right. Reactants are to the left. Products are to the right, meaning the arrow always points towards a product. And the product is what is produced, meaning it's the ending part of a chemical reaction. A catalyst speeds up a chemical reaction by giving a place for the reactants to meet. Yield is another way to say product. Aqueous means that it is dissolved in water. So when you put salt in water and it dissolves, it becomes aqueous sodium chloride. A reversible reaction, you can think of it as the double arrow. It goes backwards and forwards, and it means that the reaction can go forwards and backwards. So the products can turn back into the reactants. Law of conservation of mass states that the mass that we begin with is the mass that we finish with. It's where we have to balance chemical reactions, the reason why we have to balance chemical reactions. Synthesis, a synthesis reaction is when you go from two things to one thing. So it's going from two to one. It doesn't have to be two, it can just be multiple. So many things to one thing. Decomposition reaction is the opposite of a synthesis reaction. So it's going from one thing to multiple things, or one to two things. Single replacement reaction, we are going from an element plus a compound, and it produces an element plus a compound. Double replacement reaction, compound plus a compound, produces two different compounds. Combustion reaction is when you have a hydrocarbon reacting with oxygen to produce CO2 and H2O. Oxidation reduction reaction. An oxidation reduction reaction is when you have any change in oxidation numbers, or it's the transferring of electrons. Neutralization reaction is when you put an acid plus a base and it produces salt and water. A precipitate reaction. Precipitate reaction is a reaction that you put two aqueous substances together and a solid forms out of solution. A precipitate is the solid part in a precipitate reaction. Solubility rules. Solubility rules are given to you on your formula chart, and they tell you if something is soluble, meaning it can dissolve, or insoluble, and it cannot dissolve. Then lastly, activity series. Activity series tells us the reactivities of metals or cations, and it goes from most reactive on top to least reactive on bottom. Balancing chemical equations. A says write a balanced chemical equation with lithium when lithium is reacted with iron sulfate, and we're going to say that this is iron 2 sulfate. So when we write lithium, it's just a metal, and so what we have to make sure of is that we just write Li. Now anytime we write a element by itself, we just have to make sure that it's not a part of Brinkelhoff, meaning it's not a diatomic. So lithium's not, so it doesn't get a 2, but lithium reacts with our iron 2 sulfate. Now whenever you make a compound, you have to go ahead and write the formula. So Fe has a +2 charge, sulfate is SO4 with a -2 charge. Since they have the same number, a 2 and a 2, they reduce down to a 1 and a 1. So we just get FeSO4. And just remember we brought those down by crisscrossing. Now from here, we go ahead and write our reaction. Now lithium is going to go ahead and replace our iron. So that means that iron is now by itself. It's not part of Brinkelhoff, so it's not a diatomic. We don't put a 2. But now we have lithium sulfate. So to write lithium sulfate, we have lithium. It's in group 1, so it's +1. And then sulfate is SO4 -2. And then we crisscross here, and we get Li2. 2SO4. And we need to make sure that it's a balanced chemical equation. So when we look at this, we know that we have 1 lithium, 2 lithiums. So we put a 2 there. Now we have 2 lithiums, 2 lithiums. We have 1 iron, 1 iron, and we have 1 sulfate and 1 sulfate. And so therefore that is a balanced chemical equation between those. B, it says write a balanced chemical equation when carbon dioxide and water is used to create glucose. Glucose we might not remember, but glucose is C6H12O6. That's glucose. So you use that. Make sure you set it up where carbon dioxide, it's a non-metal bond, so it's covalent, so you don't need to crisscross. Water is just good old H2O, and it's combusting to create create glucose. It will also create oxygen gas. So there'll be a little bit of O2 over here. It's O2 because it's a diatomic. So see if you can write the rest of that out. And then C says write a balanced chemical equation resulting in the combustion of hydrogen gas. The answer to this is just 2H2 plus O2 produces 2H2O. See if you can work that out step by step and figure out how I did that one. Moving on to balancing chemical equations, it says what numbers can be adjusted in a chemical equation to satisfy the law of conservation of mass. The only thing that can be changed are coefficients. You can't change the subscripts, you only change the coefficients. So let's go ahead and balance some of these, looking at B. So when we're looking at this one, we see that we have hydrochloric acid reacting with our barium hydroxide to produce barium chloride and water. To look at this, start with your metals first. So we see right here, there's barium, we have 1 of them, and there we have 1 of them. So our metals are balanced. Look at our nonmetals. So chlorine, we have 1. Here we have 2. So to balance that out, we put a 2 right there. So now we look at it, we have 2 chlorines, but we also have 2 hydrogens there. So let's check next to make sure our hydrogens are balanced. So we have 2 hydrogens right there, and remember that this 2 is going to distribute within that parentheses. So we have 2 hydrogens there for a total of 4. On our product side, we only have 2. So how do we balance it? We put a 2 right there. Now we have our 2 hydrogens plus 2 hydrogens, 4. And then 2 times 2 is 4. So our hydrogens are balanced. And lastly, let's look at our oxygen. We have the 0 right, or the oxygen right there, but that 2 distributes. So we have 2 oxygens, and over here, guess what? We have 2 oxygens. So that is a balanced chemical equation. Remember that the coefficients, this is just going to be a 1 and a 1 since we didn't put a number there. Our next one, I'll give you a little bit of hint on this. Make sure that you start with your metals, and then you go to your ions. Okay, go to your ions and make sure we pay close attention. And a little bit of hint right here. Remember that 3 means we have 3 on the outside of the parentheses, meaning we have 3 nitrates. Okay, and then our last one, go ahead and give you the answer to this one. We just have a 2 coefficient here, and then that would make it balanced. So go ahead and look at that, see how I figured that one out. Moving on to types of reactions. It says classify the reaction below. Please note that the reaction is not necessarily balanced. Justify your answer for each reaction. So when we look at this, we see that we have 2 things becoming 1 thing. So we know that that is a synthesis reaction. Here we have 1 thing becoming 2 things. So it's a decomposition reaction. Here we have 2 things becoming 1 thing, so that would be a synthesis reaction. And then it wants us to write an example of a balanced chemical reaction for a single replacement reaction. Now, this can be any type of single replacement reaction, so it can really be anything. To pick this, to make sure the reaction takes place, pick a metal that's really high on the activity series, like lithium. So we'll say single replacement, we have lithium reacting with some sodium chloride. So sodium is Na plus 1, chlorine Cl minus 1, so it's just NaCl. So lithium is going to replace the sodium. So sodium is going to be by itself. And then we'll just have lithium, which is +1, chlorine -1, crisscross LiCl. And so we get that is our single replacement reaction, and it is all balanced. So all the coefficients are 1 in that reaction. The next one, double replacement reaction. Let me give you some hints on this one. Double replacement reaction happens between two compounds, and it produces two compounds. And so the metals are going to switch partners. And so you can write any reaction here where the metals go ahead and switch partners and it produces two compounds. Combustion reaction, I'll give you a combustion reaction. See if you can write one different than mine. So CH4 plus O2 produces CO2 plus H2O. And we need it balanced. So therefore, need to put a 2 right here and a 2 right there. Moving on to double replacement reactions. It says make a list of ions that are generally insoluble. Now you can use your star chart for this if your teacher allows you to use your star chart and you have the solubility rules. Remember what we say, things that are insoluble means they won't dissolve. Generally we're talking about some carbonates, some phosphates, chromates, dichromates, and hydroxides. Those can be insoluble compounds. That'll be our list. Next, it says determine if the reaction below will occur or justify your answer. Now, in a general double replacement reaction, the reaction only occurs if there is an insoluble product. So something that's a solid as a product. So basically what we have to do is we have to look and see if there's a solid in the product. So we look and see, is silver nitrate soluble? Well, we know that anything bonded to a nitrate is soluble. So this is going to be aqueous. Okay, so that doesn't count as a solid. Next one is sodium chloride. Well, anything bonded to chlorine except silver, lead, and mercury are going to be soluble. So this is also aqueous. So we don't have anything that's insoluble. So really this reaction doesn't really take place. They're just kind of floating in solution. Okay, with B, when you look at this, I'm going to give you a hint here. The silver is going to try to replace the potassium. The potassium is going to switch partners and come over here. Remember what you're looking for. You are looking for a solid in the product. So something that is insoluble in the product. When you find that, means the reaction actually takes place. Moving on to C. Go ahead and give you the answer here. And so we're going to have no reaction occurring here because everything is going to be aqueous. So nitric acid is aqueous and our aluminum sulfate is also aqueous. So no reaction in C. And our single replacement reaction, moving on to that. It says copy the activity series from most to least reactive for both cations and halogens. So when we're looking at this, again, if your teacher allows you, you can have the activity series. It's already given to you. And it starts with the most reactive is going to be on top, which lithium is on top. So going from our most to least reactive, so it's lithium, potassium, barium, calcium, sodium, magnesium, aluminum, manganese, zinc, chromium, iron, cobalt, nickel, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. And so those are going to be for our cations. Now our halogens, it's a list is always given to you because it's a periodic table. It's just the most reactive is fluorine and then chlorine, bromine, iodine. And those are going to be your halogen list. So let's determine if the reaction will occur below. Justify our answer. So the only time a single replacement reaction can happen is if the metal by itself or the non-metal, whatever by itself, this guy over here, is higher on the activity series than what it's trying to replace. Okay? So is gold higher than copper on the activity series? And no, gold is towards the bottom, so therefore this reaction does not occur. The next one, Now here we're looking at, so we have fluorine by itself. That's a nonmetal. So look on the periodic table. Fluorine is going to try to replace chlorine. Is fluorine higher on the list that we just made? And now it actually, fluorine is higher, so that reaction will occur. And then our last one, we have zinc trying to replace the hydrogen. So zinc is going to try to replace hydrogen. Is zinc higher than hydrogen? Yes, it is. So this happens and it produces hydrogen gas.